Alrighty, folks, we're at past, so I said that's when we would kick off. So we will kick off because I know everybody's probably desperate to go and do festive movie watching or something. So welcome to the Glasgow Azure User Group. This is meetup number 26, which is a still shock that we're at number 26. Thank you for rejoining us after the break that we had. We decided to break given everything with COVID and stuff like that. We had hoped we would have been back in person by now, but as you know from the news and stuff, things are not going well on that front. So hopefully you're all staying safe and we can get back to doing in-person meetups very soon. For those that aren't familiar with who the organising team is behind the Glasgow Azure User Group, is myself, Sarah Lean and Gregor, who are both here tonight. So if you've got any questions, any issues, reach out to us. We're happy to help with that. With that in mind, please do observe our code of conduct, which is very simple, hopefully. Be friendly and patient with everybody, be very welcoming, be considerate and be respectful. Again, if you have any issues with any of our speakers or attendees or even us as organiser teams, please do reach out to us and we'll try and deal with your issue. But hopefully we won't have any issues at all. Just a massive thank you to our sponsors as well. We have some great support from local businesses here in Scotland and globally as well. So thank you to all of them for their continued support and making these meetups be able to happen. They don't just happen by magic, unfortunately. Tonight we are blessed by some amazing speakers. So we've got Gary, we've got Keith and we've got Brett. So we've got a great speaker lineup, great diversity in terms of topics as well. Before I hand over to Gary, who is our first speaker tonight, I just want to say hang around to the end of the meetup because we do have a quiz. We have 3 great prizes. I have no idea why the first, second and third. There we go. The first prize is sponsored by AMD tonight. I do believe it's going to be some kind of hoodie or jacket or something with AMD branding. So they'll get in touch with whoever wins the quiz to organise a size and get that posted out to you. Second prize is going to be a fancy mouse mat and mouse, because who doesn't need that nowadays? And third prize will be some Lego as well. So yeah, hopefully exciting prizes and you'll stick around to the end for our quiz. But now that I've done all the housekeeping, I'm going to hand over to our first presenter, Gary. So Gary, away you go.
Thanks very much, Sarah. If you just bear with me while I share my screen, we'll do the usual. I will select it and then I will say, can everybody see my screen? And there'll be silence while Teams does its thing and eventually everybody will go, yep, well, we can see it.
Yep, I can see your screen.
All right, excellent. What is it? They say Teams meeting is the modern day equivalent of a seance. It's like, is there anybody there? Can you hear me? So the session that I'm going to deliver just now is called Decision Making in the Absence of Ground Truth, and we'll talk a bit about what that means as we go through. So a quick agenda between now and roughly 7:15, I think we're going to shoot for. Is I'm going to give you a very quick introduction to myself for those of you who don't know me. We'll unpack the title a little bit so it makes a little bit more sense. I'll talk about how things normally work. We'll define the problem that not having any ground truth gives us. We'll talk about a path to success, how to solve that problem. We'll talk about elicitation frameworks, which is a big part of the solution to this problem. And then we'll talk about projecting qualitative data onto a quantitative distribution. That is a complicating sounding sentence that will make absolute sense to you by the time we get there. And then we'll run a calculation to kind of do the maths and make the prediction that we want to make. And then I'll take questions. I say I'll take questions. Actually, I'll take questions at any point as we're going through. It's just I have to put questions somewhere on the agenda, so it goes at the end, but don't feel you have to wait to the end. If you've got a burning question, then just let me know and we'll get to it as we go through. So excuse me, quick introduction. I am the founder of a consultancy called Darach AI. So I mean, the kind of elevator pitch, I could talk about all of the kind of things we do, but basically what I do is I build cloud-based internet scale analytics and AI modeling platforms. and I will help you recruit and build the teams to operate them. And then I use both the people and the platforms we built in order to predict the future, whatever the future may look like for your particular organization. So let's unpack this title of the talk a little bit. So basically, the title is decision making in the absence of ground truth. So that really splits into two parts. There's the kind of decision making. What is decision making? And that, in terms of AI, machine learning, that kind of thing. When we talk about machine learning, we talk about statistics. Any kind of thing that you do, no matter how complicated a method that you use in order to do it, you're basically doing three things. You're either doing descriptive statistics, which basically is describing a thing. So that's how many widgets did I sell in the third quarter of last year, and how does that compare to the mean of the last 3 years? So that's descriptive statistics. Or the second thing you could be doing is predictive statistics. So for example, based on how many widgets I've sold up until now, how many widgets am I likely to sell in the third quarter of this year? And then the last one, and this is where the real money is prescriptive statistics. So that is basically based on the fact that I've made this particular prediction, what should you do about it? So based on the fact that I think you are going to sell 200 widgets in the last quarter of this year, this is what you should do. So those are the three kind of things: descriptive, predictive, and prescriptive. So that's in the decision-making thing. And the last part is what makes this talk, well, if you're into machine learning and artificial intelligence, that kind of thing, this last part is what makes it interesting. It's to be able to do that in the absence of ground truth. And ground truth is basically things that you have measured, things that you know to be true because you've gone to the ground and you have checked them. So for example, given the example of how many widgets did I sell last year, well, the ground truth is that I know how many I sold because all of that stuff went through the till. And so that would be the ground truth. How many widgets did I, each of the individual widgets that I sold. And so this this talk deals with, well, how do I still do these kind of things? How do I still make predictions given that I have no ground truth? Either the machine to measure the thing that I'm working with hasn't yet been invented, or a lot of the things that I'm using are underground assets. For example, they're buried pipelines of gasworks and things like that, and the plans of these things have long since been lost, so I don't really know where they all are. That kind of thing. Either we don't have the data because the machine isn't available to collect it, or we don't have the data because we just don't measure that thing. All of a sudden, a manager somewhere says, I want this key performance indicator so that I can make better decisions about my business. Well, you can't just magic up all of the data for that key performance indicator if he just decides on a Monday that he wants this. Okay, you have to have a time frame by which you can actually collect that data. So that's unpacking the title. That's what we're going to talk about: decision making in the absence of ground truth. So, having spoken for a while, let's talk about let's have a quick demo about how it works normally. So if we were trying to make predictions under normal circumstances. So let's just quickly shoot across here to Jupyter Notepad. Now, how's the resolution for that? Can you guys kind of see the code and everything okay?
Yeah, I think it looks fine, Gary.
Good, excellent. I was about to say you need to nod louder because I can't hear you. Okay, so one of the canonical examples in data science and machine learning is the Titanic predictions. Let's make a prediction about who's going to survive the Titanic. And this has become, well, for somebody who's old like me, it's become quite an interesting question, because the answer to the question, how likely are you to survive, depends on, it turns out I've discovered through years of giving these kind of introductory talks, and the canonical example being the Titanic survivability. It very much depends on your opinion is driven very much by how you first came to know about the Titanic. So did you learn it in history at school when it was all about the stiff upper lip and women and children first? In that case, you will be of the opinion that someone who is female, regardless of their class or their age or whatever, is more likely to survive than a male. But if you were introduced to the Titanic story by watching the actual movie Titanic with Kate Winslet, then in that movie they portrayed it as the rich survived and the poor third class passengers all kind of drowned behind locked gates and stuff like that. And so you're of the opinion that the rich survived and the poor didn't. So now it's become quite an interesting question. So here's how we would normally do it when we have this ground truth, where we have data. So first of all, in the first cell, we're basically, so in order to enable us to make a prediction about survivability, we have to do a bunch of things. So the first cell here, we're just going to bring in some libraries that we're going to read. Next thing we're going to do is we're going to create a data frame by reading in the Titanic CSV data. Now, the Titanic CSV data of all the passenger information and survivability and things like that. It's widely available on the internet. You can, if you want to play along at home, you can go and download this from lots and lots of places. So we read that in, and we'll have a look, and we'll see what data we've got. So this is the data that we've got in the Titanic. CSV file, there's a passenger ID, which doesn't really mean anything. It's just an identifier. A Boolean class as a number, a 1 or a 0, as to whether that person survived. The passenger's class, whether it was first, second, or third class. Their name, their sex, or their gender, their age. The next few we're going to really just ignore pretty much. The column 6 there is whether or not they had siblings aboard. Then we've got how much they paid for their ticket, what cabin number they were in, and whereabout they embarked. A lot of people think that the Titanic sailed from Southampton and it just sailed out into the Atlantic. It didn't. It had a stop in Belfast as well, so you could have got on at Southampton or Belfast or whatever. So what we're going to do is, we're going to be asked, so we're going to simulate the fact that we've been asked a question of, we would like to predict the percentage likelihood of survival based on the age and the sex of any given passenger. So that is fine. So if we look down, first of all, if we look at age, which is item 5 on that list, we can see that all the others, if we look at passenger ID, we can see that there's 891 individual unique passenger IDs, but if we look down at column number 5 there, we see age. We've only got 714 actual ages. So if we sum up how many is missing there, we can ask the data frame to go to the age column, check for the ones which are null, and sum them and give us a total. We can see that it's 177. So one of the things that we normally have to do in machine learning and artificial intelligence is we have to clean the data. So this would be an example of, even if you do have ground truth, it's very rarely in the right kind of format. You always have to faff around with it in some way, and that faff around is a technical term, obviously. So what I'm going to do here to kind of interpolate or fill in the missing data is I'm going to find out what the mean age is, and I'm going to find out the standard deviation. So that will give me a mean age plus or minus a variance. So it'll be something like, the mean age is 25 plus or minus 3 years, okay? And then what I'll do is I'm going to find the number of nulls in the age. And then what I'm going to do is for each of those, I'm going to compute a random number between the mean plus or minus the standard deviation. So that's going to be this range here. So I just create a random integer, which is either going to be somewhere between the mean minus the standard deviation and the mean plus the standard deviation. And how many of those do I need? Well, I need one for every null that I have in that data set. So that's what I'm going to do there. So basically, I calculate a whole bunch of random ranges between the mean plus or minus the standard deviation. And then what I'm going to do is I'm going to copy out the slice of the age, and basically for for every one which is null at the minute, I'm going to replace it with the random age. And then I'm just going to type that as an integer just to make sure. So if we do all that and we calculate that, we run that, now we can see we should have 0 empty ages. So what we've done now is we've replaced all the null ages with some kind of sensible value. Now, the next thing we have to do, if we look back up here and we look at the sex, which is column 4, we can see it's an object, and that's kind of Python speak for this is a string. And that doesn't really help us because when we're doing machine learning or artificial intelligence of any kind, maths only works with numbers. Okay, you can't do maths with strings, and so we have to do something about that. So what we're going to do is we're going to say to the data frame, please give me the column labeled sex. And what I want you to do is I want you to map that, and every time I want you to map a function against that. And what I'm going to do is I'm going to say every time I come across the string male, I'm going to replace that with the number 1. Every time I come across a string female, I'm going to replace that with the integer 0. So I'm just going to do that, and that's going to make us all nice and numerical. So what I'm going to do is I'm going to grab the independent variables. So independent variables, when we talk about machine learning and artificial intelligence, is the independent variables are the thing which drives the dependent variable. So survivability, for example, is a dependent variable, and it's dependent upon age and sex, and it's not probably dependent upon a bunch of other things, but we're only looking at it in terms of age and sex. So age and sex are independent variables. They're not driven by anything. Excuse me. And we're going to grab, and they always go on the x-axis. The independent variables go on the x-axis, and the dependent variables go on the y-axis. And we're going to grab that, and the dependent variable is whether or not you survived. And then what we're going to do is once we've got those, we're going to fit a model. And fitting a model basically says, I'm going to train a model. I'm going to look at all of the data which is available, all the ground truth data, which is in that titanic.csv file. And I'm going to make a calculation. I'm going to calculate a logistic regression built based upon the information, the ground truth that's contained in that file. So once we build that up, we get a logistic regression model. And then once we've got that model, we can start to make predictions against it. So if we see here, if we've got an adult, age 25, and we'll say this adult is a female, and we say, what is the probability that that person would survive? We say, well, according to the ground truth data we've got, actually, if you were 25 years old and you were female, you had a 74% chance of survival. And if we do exactly the same thing and we simply change the sex to be male, we can see that all things being equal, a male of 25 years old only had a 20% chance of survival. So that kind of answers that question of, which kind of model was correct. Was it the kind of historical model of women and children first, or was it the kind of more modern Hollywood model of, the rich survived and the third-class passengers drowned behind locked gates? And by doing this work, we can say, first of all, we can make those predictions and get the results, but we could also settle that question that actually the historical perspective of women and children first was actually correct. It was actually what happened there. So this is how things are done normally when we have ground truth, when we actually have data to work with. So if we jump back in here and we say, right, so let's define the problem. The problem is very simple. How do you do that kind of thing when you don't have any data? So we're in the scenario where a manager has said, hey, I need this new key performance data. And because it's a brand new thing, we don't have that data. We haven't captured that data. So we have no ground truth. And we can't just, people who work in the machine learning and artificial intelligence space get paid a lot of money. So getting paid a lot of money, when somebody brings you a problem like that, you can't just shrug your shoulders and go, oh, I don't know, sorry. You can't have that for 6 months because we need at least 6 months worth of data. You have to be able to do something. So the something that we're going to do is we're going to do the best that we can. And what we're going to do is we're going to find within the organization, we're going to find subject matter experts. It doesn't matter what key performance indicator you're asked to come up with. There will always be somebody preferably a group of people in your organization who have subject matter expertise because they've been doing that particular thing or they've been looking at that particular area for the last 20 years or 5 years or 15 years or however long that they've worked there. So they have an experience of doing that thing. And what we're going to do is we're going to elicit their opinion. Basically, we're going to ask them, what do you think is likely? What do you think the likely scenario is in this area? And they will say, I think it is this. So we use a framework and we elicit their opinion. And then based on that opinion, we map that. Somebody's opinion is known as qualitative data. It's not quantitative because you can't measure it and you can't repeat it. It's qualitative. The difference between qualitative and quantitative data is you can think about qualitative data as being, in this case, someone's opinion. So if you asked me a question and you asked Sarah a question, you might get two different answers because it's based on our opinion. So that's qualitative data. Quantitative data is usually something that you've measured, right? So if you ask Sarah to measure a distance and you ask me to measure the same distance and we're both using accurate devices, then you'll get the same answer. So with quantitative data, you can repeat the measure and get the same answer. And with qualitative data, you can't necessarily ask the same question or repeat the same measure and get the same answer. And so that's the difference between qualitative and quantitative information. Unfortunately, all of the frameworks that we use within machine learning, within artificial intelligence, they really require quantitative data and not qualitative data. So we have to have some function which will map a qualitative opinion onto a quantitative distribution. So that's in that center bit there. And then once we have numbers, we can run our calculation, we can run our model. So that's the kind of path to success that we're going to use. And how we do that is we use an elicitation framework, and I'll run through this as quickly as I can. So the elicitation framework, it elicits an individual answer. And then once you've got an individual answers from a group of individuals, you then discuss within the group anything, basically the outliers. So you may have a bunch of people of experts who have kind of congregated around a center number, and you may have experts who are at the extremes. And it's always, you should never just dismiss the outliers, never just dismiss the extremes. You should always have that discussion because it's entirely possible that somebody who gives you an outlier number actually has more information or different information or better information than the group as a whole, and that's why their guess, their elicited figure is outside of the norm. So you always have that group discussion, and then once you discuss that, you can then kind of congregate and get an agreement as a group around the actual data figure that you want, and you just keep going around that loop for every kind of piece of data that you need in order to complete your calculation, and that will give you a description of a qualitative guess as to what the real data should be. And we'll look at that in a bit more detail when we get on in a minute. But that's how any kind of given elicitation framework works. The elicitation framework that I like to use is called Shelf, and we're now on version 4. I'm going to skip at this point and just actually use their actual slides from their actual deck, both because I don't want to get caught on copyright nonsense, and the other thing is they basically explain their own framework better than I could, so that makes total sense. So this one is called Shelf because it's the Sheffield Elicitation Framework from Sheffield University. So the first thing we're going to do when we're going to ask people, so let's say we're going to take the hypothetical example of we want to calculate how much risk a particular organization has in its assets failing. So this particular organization has a bunch of assets. It does annual maintenance on those assets. We want to know what is kind of the minimum amount of maintenance that we can get away with, or more importantly, after we've done our routine maintenance, how much risk still exists in our network from the possibility of assets failing. And right now that's not measured. So we can take the idea that a manager wants to know this, but we don't measure those things. We don't measure every time a particular piece of equipment fails. So there's no way for us to calculate it. We just need to speak to the people who have been doing the routine maintenance year in, year out for the last decade or so, and actually ask them what they think their, what's their best guess towards these values is. So if we think about risk is simply the likelihood of failure multiplied by the financial impact of that failure. So we need two figures to be elicited from the subject matter experts. One is how likely after maintenance is a particular asset to fail in percentage terms. And the second figure we need to elicit from them is if it does fail, what is the financial impact of that failure? And then we can calculate the risk. It's just the likelihood of it failing times the impact if it were to fail. So the first thing that we ask the experts to do is to set plausible limits. And plausible limits is what we're going to do is we talk about in the framework talks about this idea of a quantity of interest. So we refer to that quantity of interest as X. In this particular example, if we're talking about how likely something is to fail, we're talking about and we're talking about a number between 0 and 100, right? We know these are the absolute limits, not the plausible limits. What we're looking here, which is what we're looking for, but the absolute limits. You can't have less than no chance of failure, and you can't have more than an absolute guaranteed chance of failure. So those are the absolute limits, but within that range, we will have a plausible limit for what that likelihood is likely to be. So we're going to set the lowest plausible limit, and that's going to be denoted by the letter L. And how you should guess that, so we tell people who are running this thing, how you should judge that is to say it's extremely unlikely that the true value of X could be less than that. Now, not impossible, because we know if we're dealing with likelihoods, the absolute limit is 0, right? So it could be 0. So it's not physically impossible for something to be close to 0. It's just really unlikely that nothing has no chance of failure. I mean, even if you just buy an asset, if you buy a light bulb, for example, straight out of the shop, right, take it straight out of the box and plug it in, there is still some chance that that bulb isn't going to work. Okay, so it shouldn't be 0. It's just not very likely to be less than X. And that's what you're going to choose for your lower limit or L. And then you're going to challenge that. So you're not just going to make a guess, but you're going to challenge yourself to see if that guess is right. And how you're going to do that is you're going to just imagine at some point in the future there was a way of measuring the thing that you are having to elicit, okay? And that somebody came back and told you that they had measured this thing accurately and it was less than your value, okay? What is your reaction going to be? If your reaction was, is that, well, actually that's possible, my judgment was just flawed, or your reaction could be that you just think that's broken, right? Your machine doesn't work. If you're telling me that you've used the machine and you've measured that and it's come back with a value lower than what I think the lowest plausible limit is, if I think that your machine must be broken, then I've pretty much got my L in the right place. But if I think that, yeah, sure, that could be, yeah, that's reasonable, then my value for L is in the wrong place and I should lower it. Okay. And then guess what? We do exactly the same thing for the upper limit. We just go through exactly the same thing. Should be extremely unlikely to be greater than that upper limit. Not physically impossible, but just unlikely. And then we write that down. And we challenge the value in exactly the same way as we challenge the lower value. And now what we've got is we've got our personal plausible range for X. We know that X lies somewhere between that lower value and that upper value. And we think that it's going to be here, and it's extremely unlikely to lie outside of that value. So now we have that range. So once we've set that range, the next thing we're going to do is we're going to elicit from them the median. And what we're going to say is we want to write down that median, and that median should be, you should judge it to be as equally likely that the true value of X is below the median or above the median. Okay, it's equally likely. Now you shouldn't just plonk it in the middle and say, well, now it's 50-50, because it could be that actually your X is more likely to be towards the upper limit, or actually more likely to be to the lower limit. But wherever you place it along the number line, you have to think to yourself, it's as equally likely for it to be above that value as it is to be below that value. So we've got some examples here. Here we've got X is a bit closer to U. I mean, still, we still think it's equally likely to be above or below. Here, X is much more likely to be near the U, but you should judge it equally likely that it's above or below that, no matter where you put your M. Okay, and then you want to write down that value for the median. Again, we need you to challenge the median, and how we do that for the median is we say, suppose we offer you a large prize if you can guess correctly whether X is above or below. You don't lose anything if you're wrong, but if you're right, you get a big prize, right? If we ask you to guess and you guessed purple above or yellow below, then that means that your M is in the wrong place. Right? If you actually were asked to guess and you said, oh, it's more likely to be in the purple region, then you have to move your M further up. Okay? Increase your M. All right. You know you've got it in the right place when you genuinely don't have a preference. You go, well, it could be either. I would just be guessing, right? It's as equally likely. If you can say that, then you know you've got your M in the right place. Then we can kind of refine that median, right? If you can never be really precise, but if you could increase M just a little bit, still feel that it's equally likely to be above or below this median, try increasing your M a little bit until you think, oh no, it couldn't possibly be above that, right? And then do the same thing for going below. And then once you've done that, you've pretty much guaranteed to have gotten your median in the right place. Now, the quartiles is really simple because all we're going to do is we're going to do exactly the same thing, but instead of placing M, the median, between the lower and the upper, we're going to do two quartiles. We're going to do quartile 1, which is going to be between the lower and the median, and we're just going to treat that as if we were placing the median, but we've replaced the upper level with the median. So that's what we're going to do. So we do that for quartile 1. I'm not going to read this whole thing out again because it's just exactly the same as it is for M. It's just that we've taken a binary chop of the entire number line, and you can think about placing quartile 1 as placing an M, but only in the bottom half of the entire range. And then we can do that exact same thing like so. And then we're going to challenge ourselves again. And then we're going to do quartile 3. And quartile 3 is exactly the same, except you're doing the other side of the binary chop, where it's the same as placing an M, except you've replaced the lower bound with your previous M value, and the upper bound is still the upper bound. So you're placing a median, but in the upper half of the entire number line. So you can think of quartile 3 as being that. So again, exactly the same thing. You challenge yourself. These are the kind of things that it would look like. And just in exactly the same way as the median one did. And then we write that down. Then we go into our group discussion, and we have this idea of the rational impartial observer. It's you don't want to. So basically, you can read this as I'm speaking because you can read faster than I can speak. But basically, the idea is everybody is there with their different lengths of time they've been working there, different expertises, different kind of background. But what you have to do is you have to kind of come to a mutual understanding. And the idea of having a mutual understanding and getting that kind of consensus, the idea here is no one person's view holds sway. The idea is that you have this imaginary person called the rational impartial observer. And the idea is it's this person. The idea of the rational impartial observer is that this person has listened to all the discussion and this person understands all of the arguments. And having listened to all of the discussions and having understood all of the argument and being both rational and impartial, what decision is that person likely to come to? It doesn't have to be identical to any one person in the team, but it's then what are they likely to think? And it's that thing It's that measure, that decision is the one that you go with, right? Not necessarily any one person having sway. So you can kind of put all of the kind of pressure on this imaginary person. So once we've done that, what we get is we get what's called a 5-point description. So this 5-point description describes a distribution of where X is going to be. So it's going to be no lower than L. It's going to be no more than U, and we're going to have the median somewhere in the middle, and then halfway between the lower value and the median. And when I say halfway, I don't mean by distance, I mean likelihood of the value being there. Halfway between the lower and the median is going to be quartile 1, and then halfway between the median and the upper bound is going to be quartile 3. So we've described qualitatively what that distribution is going to look like. Well, having described it, we then have to actually generate that distribution because we need to be able to do maths. So now, having talked for a long time, I'm going to go on and give you a quick demonstration of what that looks like. So if we go back here and we just have a look at that generating the data, what we're going to do is, again, I'm going to pull in some libraries that I'm going to use, but this is the function that does the work. So the function that does the work takes that 5-point description that I've already talked about, takes that 5-point description, plus it takes another parameter, which is the size, and it says, hey, you're basically telling this function, give me size number of examples, so 10,000 say, so give me 10,000 numbers in a distribution, 10,000 pretend measures in a distribution which is described by this 5-point description here. Okay, so that's all we do. So we know, because of the way we've set this up, that so what we're going to do is, if the size isn't an odd number, add 1 to it, because we want to put the median right in the middle, where it's 50%. It's just as likely to be below this number as above this number. Well, to get that right, we need an odd number. So we're just going to add 1 to the size if it's not already an odd number. And then we say, we know that 25% of the data points are between the lower bound and the first quartile. So 25% of all the points have to be in there. So we just generate that number of points within that area. We know that 25% of the data is then between quartile 1 and the median. So we do exactly the same thing, generate 25% of however we need in that area. And then just repeating that. Same for, we know there's a 25% of the data is between the median and quartile 3. And lastly, the last 25% is between quartile 3 and the upper bound. No matter where they are, they don't need to be evenly split, but we understand that that's where the data is, regardless of where you've placed them. Then once we've done that, we place the median, and then we sort it to make sure the median is right in the right place, and then we return that data. So if we just read in that function, what I can then say is generate a sample which is described by this 5-point description and give me 10,000 examples of that. So if we run that, we can create 10,000 examples, and then we can test to make sure we got this correct. You know, what is the 25th percentile, the median? Sorry, what is quartile 1? What is the median, and what is quartile 3? We can actually we can actually measure it after we've done the distribution. And we see that it is 66, 75, and 85, 66, 75, and 85, which is what we asked for. So we know that we've got that right. And so now we can actually plot to show what that distribution looks like. So what we've done is I've taken 7 of these things just to show you, created random lower, median, and upper bounds based on 0 to 100 as a percentage, and this is just to give you some idea of what these things can look like. So we ask different people for their different opinions, and they can generate a whole bunch of different distributions. But we know that once we've got the actual description, we can then generate a distribution like this, and we actually can now start to do with some maths because we've got that distribution. All right, so that's how we build. That's how we move from qualitative data, i.e. asking someone's opinion, to quantitative data, i.e. now we have a distribution full of numbers that we can do maths with. So quickly, if we just go back here, the last thing we have to do is once we have generated that distribution, once we've moved from quantitative to qualitative, we can then say, right, well, now that's great. Now let's do a calculation. So back to our demo, and if we go run the calculation, what we're going to do now, so as I said before, we had this idea of an asset. So an asset is going to be in a particular region. Regions are broken down into areas. Areas are broken down into sections. So each asset has an ID. It's in a region, or actually it's in a section in an area in a region. It has this description of the likelihood of failure, and it's got this description of the likelihood of impact, because obviously I didn't run through the elicitation framework a second time because it was frankly boring enough, very important, but not particularly exciting. So boring enough the first time round, but obviously you can repeat exactly that same process as you went through to then get figures for the impact, the financial impact of the failure. And we can put that description in here. And then of course we have the risk, okay? And then we add a little helper function here, which turns that object into a dictionary. And I'll show you why we will use that in a minute. And then here, I'm just going to generate some random assets for this imaginary organization of ours. We're going to say we're going to have 5 regions with 10 areas in each of the regions and 20 sections in each area in each of those regions. We're going to create a new asset. We'll create its ID just with a GUID. We'll put it in a region, in an area, in a section. We will then create we'll then generate random likelihoods and impacts. We'll generate those random things, and then we'll add that asset to our list of assets, and then we will return our list of assets from that random generator. This is the function, and it just creates that random 5-point description that we're going to fill in these parts. That's all that function does. And then we're going to generate that data that does exactly the same as I just described before. It creates the distributions from those 5-point descriptions. So if we read all of these functions into the notebook, we can then generate this group of assets, like I said. And then we come to calculating the risk. And as I said before, the risk is simply the likelihood times the impact. But what we have now is we have an entire distribution for the likelihood, and we have an entire distribution for the impact based on these descriptions. So actually, the risk is the mean of the likelihood multiplied by, the mean of the likelihood distribution multiplied by the mean of the impact distribution to get the actual risk. So we're going to calculate that, and then we're going to return the risk. And we're going to do that for each of the assets in the asset collection. We're going to calculate that risk for them. So we just go ahead and do that. We'll give that a little minute to catch up because it takes a bit of time to do that. There we go. And then once we have done that, once you've got a collection of objects, we can start to do things like, well, give me the minimum risk. And the minimum risk is I just loop through all of the assets looking for the smallest one, and I replace, if I find one that's smaller than my current minimum value, I just replace it. We can do exactly the same for the maximum by just swapping the sign around, and then we can plot them. So here, for example, just using the list of objects, I can now do this, and I can plot the top 10 riskiest assets you've got. And all I've done here is I've taken the last 4 digits, I think, from the unique identifier, and I can say, look, here is your most riskiest asset at 171,000, and then your least riskiest down here at 170,000. So the top 10 riskiest ones run between 170,000 and 171,000 pounds of impact should they fail. So those are the kind of important calculations that we can do now that we've taken experts' opinions and we've turned them into numbers. But here we can go one step further, and what we can do is we can actually turn this into a data frame. We can take this list of objects and we can turn it into a data frame. So if we just quickly do that, now you can see we've got this table where we've got the region, the area, the section, and we've got the risk here. And then once we've done that, because it's then a table, we can start using pandas to actually drill into this thing. So for example, we can repeat the exact same thing. We can say, show me a sum of all of the risks for all of the assets by region. So basically, give me a graph of all of the most riskiest assets by region. So we can ask it to do that, and we get basically a similar kind of graph. But because now it's a data frame, we can actually start drilling in and say, well, actually we can group by more than one thing. So show me which is the riskiest area, but group these by region by area. So we can do the same thing here. And now we actually say, well, actually the area that's covering that has the most risk attached to it is actually region 3 area 1. So we can see the measures there, and we can keep going with that and say, well, actually then what is the most riskiest section? So we can basically just build this out for as long as we want, and we can drill into it really easy. So now we've got it grouped by region, by area, and by section. So again, we can run that kind of thing. And now we can see that actually the section with the carrying the most risk is region 3, area 1, section 15 has our most risk. So now we've gone from, by using this principle of eliciting the information from experts and then mapping it to a distribution and then doing our machine learning and artificial intelligence, we've gone from a position where we don't have any evidence at all and we can't make any decisions to actually here we can say, well, not only can I actually tell you things, but I can actually tell you that we believe the area which has the most accumulated risk is region 3, area 1, section 15, and here's the top 10 riskiest assets. And so we've gone from having no information at all to really being able to drill in at quite some depth and to be able to provide key performance indicators for management. And at the end of the day, of course, that's what we get paid the big bucks for. So on that note, I have overrun by 3 minutes, I'm afraid. So if we can keep questions down to a minimum, if you do have a question and we don't have time to get it out, feel free to email me or ping me up on Twitter. My Twitter handle was at the start there. It's just @GaryShort. And I can answer your questions then. But for now, I'll take maybe a couple and just overrun by a nice round 5 minutes. So I'll take a couple just now, if there are any questions. But right now, I'm going to stop sharing my screen because it's quite disconcerting not being able to see anybody for the last 45 minutes.
Awesome. Thank you so much for that, Gary. That was really, really informative.
No problem.
Anybody get any questions? They're all going to be a shy bunch tonight, and we know they're not shy because they're all from Scotland, or most of them are.
Yeah, absolutely. Like I say, if you need a couple of minutes to think about things or whatever, feel free to tweet me, and I'll answer your question.
I suppose one of the questions I had actually, Gary, is you were running that in Jupyter, which I think was running on like a local host box. What do you do if you take? That's obviously great from running on your PC, but how do you take that and put it into, say, Azure or AWS? Can you just lift and shift that? Do you have to use a different product? What's the process for all of that?
So basically you move from, hey, this works on my machine with the limited data that I've got, all the way up to, now that's great, but now I want to calculate it for everything. I want the whole thing. So how difficult that is a function of how much I need it to scale. So right now I'm running it in Jupyter on my own machine. If I want to push this into the cloud, I've got a bunch of options. I can put it into Azure Notebook, and then I can put the data in Blob, and I can call the data from Blob storage from Azure Notebooks. So I could do that. If that's what I'm going to do, it's a pure lift and shift, right? No change, no problem. That works okay. If I want something a little bit more control over that, and I want my own server, I can spin up a data science virtual machine. Again, I can either I can pull the data either from Blob storage or from SQL Data Warehouse or whatever. Again, so no change whatsoever involved there. Now, if I need to scale massively beyond what I can do just with Azure Notebooks or with DSVMs or whatever, and I need to go to Azure Databricks, right? At that point, I move into a distributed environment. Okay, and the only real change I need to make there is that I can no longer use a pandas dataset. So here I pulled all my data in and I used the pandas data frame. I have to swap out the pandas data frame for the for PySpark data frame. Okay, the only difference they are pretty much the API is pretty much a 1-for-1 match. The only real difference between pandas and the PySpark data frame, or the RDD, which is basically the data structure underneath, is that the PySpark data frame has an understanding of what it means to be distributed. So when I do something, when I map a function to a group within the data frame, what happens is each of those groups then gets sent to a node for calculation, and then they all get gathered up again. But still, the only real change I have to make is to swap out pandas data frame for PySpark data frame, and the rest of the code will just run. And now all of a sudden, I'm running on an Azure Databricks, and I can pretty much, at that point, my client is going to run out of checkbook before I run out of resources and compute in order to go. So that's the short answer to your question is the amount of work that you have to do is a function of how much scaling you need. But even at the absolute top, you need to scale right up to Databricks. It's a very straightforward change, just swapping out pandas for PySpark.
Okay, sounds good. Any other questions from anybody before we?
I've got a quick question, if that's all right.
On you go.
How easy is it to do prescriptive analytics on this stuff?
Well, so here what we did was the very simplest thing, right? Which was we did descriptive analytics. We said, hey, based on what your experts think, this is what your risk profile looks like. All right. But once we've done that, we've got all those distributions. We can do everything. So we can say, okay, so based on this information, I think the 10 most likely assets to fail based on their high likelihood to fail are these assets here. So it's very easy to then do predictive calculations. And because of that, it's also very easy to do prescriptive. So you can say, so you go from no information at all, you do the elicitation framework, you've got the risks, you can then say, based on that, I predict these top 10 assets are likely to fail. Based on that, you can say, and so prescriptively, I say you should up your maintenance on these 10, because even after your routine maintenance, you've still got this high level of risk. So maybe do your routine maintenance, but in the off quarters between the annual maintenance, then maintain these 10 or X number of assets outside of band for that. So it becomes very easy to do each of the three types, the descriptive, the predictive, the predictive, and the prescriptive statistics. It becomes very easy once you've done that elicitation and then the mapping of the quantitative to the qualitative. Once you've done that mapping from quantitative to qualitative, everything else is the same. It's just exactly the same as if you had that ground truth data to start off with. So what makes elicitation frameworks extremely powerful? You're in that position as if you had that data.
Awesome. Any other questions before we let Gary go?
No, like I say, it's not tablets of stone. I don't think you've only got this one opportunity. If you think of something else, just tweet me, and if it's a more complicated answer, I'll maybe DM you and ask for your email address, and I'll maybe email you samples and questions. But other than that, we can do it all on Twitter. You don't need to go, oh, suddenly I've forgotten, but Gary's away for his tea now, so I missed the opportunity.
Okay. Awesome. Thank you so much, Gary. That was really good. Thank you for joining us.
Thanks a lot. Thanks for inviting me. I really enjoyed that. I'll catch you guys later. Thanks a lot.
Okay, see you later.
Bye.
Next up, we have Keith. So, Keith, you're free to take the floor as you wish.
Thank you. Just be right with you. Okay, let's see. I'll just go ahead and share this. Okay, are those slides showing okay there?
Yep, we can see your slides.
Great, thanks, Sarah. Okay, excellent. Well, thanks everyone. Welcome to Scrooge's Guide to Saving Money on Microsoft Certifications. A big thank you to Sarah, Gregor, and all the wonderful sponsors for tonight's event. I'm Keith Atherton, and I've been a software developer for over 20 years. And in that time, I've been using mostly Microsoft technologies. But recently, I've been studying towards some Azure certifications just to learn more about Azure. And I picked up a few tips and tricks along the way that I wanted to share with everyone. So that's what this presentation is all about. Obviously, it's a bit jokey with Scrooge and saving money, but we will cover some paid options as well as discounted free options too. So for those new to it, Microsoft certifications are currently role-based these days. We can see on the right-hand side there, we've got different roles like developer, data scientist, and so on. And typically to earn a certification, you pass a few exams, and the current levels we've got fundamentals, and that's to get an understanding of the concepts. There's associate level, that's a bit more hands-on, and expert as it sounds. So far, I'm quite early on. I've passed a couple of certifications so far, currently studying for the Azure Data Fundamentals, and I do have a path in mind. So primarily, I'm a developer. I do a lot of design and architecture as well for where I work. So I'm heading towards the Azure Solutions Architect Expert ideally, but I'm just going to go with roll with the punches and see how I go along the path. So here's part of the chart for the Microsoft certifications. We can see lots of options there. Again, I'm going for the Azure side of things, but there's Power Platform. There's also security just off the chart below there as well, and plenty of other options as well. So lots of interesting topics there. What we'll do is we'll have a quick look at some free learning resources, things that I've been using so far that have worked really, really well for me. So the main one for me is Microsoft Learn. That's a really brilliant portal. And you can see on the right-hand side there, we've got the breakdown of the modules. There's lots of really good reading content, some videos too. And even with some of the modules, there are some hands-on labs, so you can actually try and use the services as well. Really cool. And some of them have got like a sandbox where they'll give you an environment for a couple of hours, and you can play around in this sandbox, sometimes without charge as well, just to get hands-on, learn a bit more about the practicalities. Microsoft Docs as well, that's another good option. There's plenty more reading in there just to dig into the details of the different services as well. So we'll look at some paid options as well. Now there's some really good online courses. So the one I've used a few times is Udemy, really, really good. The screenshot just there is Scott Duffy. He's provided several courses, and Scott and many other instructors actually keep their courses up to date. So one thing that can happen with the certifications is they can change quite often. There's new services coming in, or they may retire some. So the good thing with Scott's course there, you can see October 2021 is in the title. And the screenshot below is from the Microsoft certification site, and we can see October this year, October 2021, was last when the content was changed. So you've got a bit of confidence with some of these courses that it's got the latest and greatest changes in there as well. Last time I checked, that course was about £50. I did get a bit cheaper on sale. It was just fluke, just the timing when I was looking for the course. But pro tip, unless you're in a hurry, I do notice that Udemy have quite frequent sales. So just one thing to bear in mind. Another favorite for me is Pluralsight. I've been very happy using them. This is the monthly subscription type of model they have, just like Netflix and so on. There are various options, individual, team, so on. One thing that I found really good with the premium option in particular is you get a bigger course catalog. There's some more certification learning paths on there, and sometimes practice exams as well. So if you can stretch the premium, or if your employer can stretch the premium, it may well be worth it. LinkedIn Learning is another portal I've used. This is have LinkedIn Premium, and LinkedIn Learning is a service that comes with that, and I've been very, very happy. I've noticed there are a few certification paths there, and we've got Azure Fundamentals showing on the screen. So again, really good video content. I've been very happy so far with that. So we'll have a quick look at some higher cost options. It just depends on your situation. The first one we'll go into is the learning partners. So this is Microsoft Learning Partners. It could be external companies providing the training. And on the right hand side, you can see the UK's list of some of the Microsoft Learning Partners just there. And I've used some of those myself. Learning Tree, New Horizons, QA. I've used those at some consultancies that I've worked for before. I've been very happy with all of them. But the benefit with this is that you'll likely have a knowledgeable instructor. You can ask them questions, dig a bit deeper into things if you don't if you don't have a full understanding. So of course you'd pay a bit more for that kind of service as well. Another option for Microsoft Learn is there's a link to the instructor-led courses. Similar thing. Instructor can give you in this case, a 1-day or a 2-day course on Azure Fundamentals. And again, you'll have someone on hand you can ask questions of. So again, if that's what you need or if that's what your employer can provide, that can be worthwhile too. So we'll have a very quick look at the breakdown of some of the certifications. We'll start with this fundamentals one here, this Azure Fundamentals. So we can see there's to earn the certification, we need to pass one exam. That's £69. So after VAT, that's £82.80. And if we compare with the expert certification just here, I'm just looking at this Azure Solutions Architect Expert. Again, there's one exam we need to pass for this, costs a bit more, £113. But also there's a prerequisite on one of the associate level certifications as well. So just a quick adding up, just to get a ballpark idea of cost, you can see that total of £271 there. So that's really where this talk came about. If you was after several certifications, I don't know, 10, 15 plus, let's say you didn't pass first time, you needed retakes as well, the cost can add up. So that's why we're going to look at some discounts and some free options as well. Quick note on the renewals as well. That changed roughly this time last year. That's now a free option instead of paying for the full exam and taking the full thing again. I've not done it myself, but I've heard you can do it for Microsoft Learn from home. It's free, and you just need to pass the Delta. Just really the things that have changed since you passed the certification. So we'll take a look at a couple of discounts here. So there's a really cool one Microsoft have at the moment for job seekers impacted by COVID. Let's say you've been furloughed or lost your job, and students as well, that you can actually schedule the exam for $15. Now, there are other terms and conditions, so it's worth looking into that to see if it applies to you. And also this offer expires at the end of the year at the moment. Hopefully that will be extended, obviously, with the ongoing situation we've got with the pandemic. Another one I've come across, which is really cool, is 30 days to learn it. And you can see with the roles on the right hand side, if you see the one you're after, you can actually take that challenge. And if you complete all of the challenges within 30 days, you'll actually receive an email with a 50% exam voucher at the very end. And I actually did that for the Azure AI Fundamentals, which I took recently. And I think the email came through like the day after I passed the challenge. So another really good option. Another one that I wanted to mention really quick was the Ignite Cloud Skills Challenge. This actually did end at the end of November, but it was really cool. There was 12 challenges. You can see some of them just there. And if it was similar to 30 days to learn it, if you completed all of the Microsoft Learn modules within that time, they actually awarded you a free exam voucher. So really a really good option. Hopefully they'll bring that back for future Ignites or future events. So we'll come on to the last one. I've saved what I think is the best till last. And this one wins the Tam Mullen Award, because and for those of you who don't know, Tam Mullen is a notoriously stingy character in a sitcom called Still Game, one of my favorites, and he always tries to blag things for free, and this is no exception. With the Microsoft Virtual Training Days, before the pandemic, it was just Microsoft Training Days. You could go there in person. Really, really cool. I've done maybe 3 of these now. I did one in person before the pandemic, and I think I've done 2 since virtually. On the right there, you've got some options with the different courses with some availability there. It's typically training over 1 or 2 days. You get a great instructor. I've been very, very happy every time, and it's free training. And at the end of it, you also get awarded a free exam voucher. And I found this with the fundamentals in particular. I've not gone above to associate or anything else just yet. But they've arrived just within a few days of watching the good content. So it's a win-win, really, really good option. And it's maybe a good starting point if you're looking to get started with Azure fundamentals or AI or data. And the very last thing I wanted to mention was, I'm sorry, I had to get a cheesy stock photo there. If you could get employer support as well. So if your employer brings in external trainers, or if they pay towards a Pluralsight subscription, or if they have one for the department or as a team, that is, that could be something to approach them with if it's not there already, or contributions towards your exam costs or anything else. But it's not just the money as well. I think getting the time to study, getting the time to learn new skills as well is very valuable, particularly if you're very busy as well. That could be more valuable, I would say. So just some things to think about if you need some support or assistance. And that's the end of the talk. So thanks everyone for listening. If you've got any questions, if there is time now, feel free to ask. If there isn't time, my contact details are on screen. Please feel free to contact me directly. I'm always happy to help if I can. Thank you.
Awesome. Thank you, Keith. The Tam Mullen Award is genius, actually. That's brilliant.
That's my favourite slide
Had to do it. I thought stingy, that's the first person I thought of.
Actually, on that virtual training day, that's actually a really great call about the free voucher that they do. Watch out if you can't find a UK-based one, because see some of the European Microsoft subsidiaries, they actually do it in English as well. So you can attend that and learn that as well. So don't, if you see the UK calendar's empty, take a look at the European one, because sometimes they do it in English as well. So that's another top tip. And so, yeah. Has anybody got any questions for Keith while he's here?
I think we've got a hand up.
Oh, have we? Well spotted, Gregor.
Oh, great.
Yeah, if you want to come off mute.
Greetings from the United States. A great talk.
Oh, yeah.
A lot of good content.
Thank you very much.
But if I could please ask, sir, what would you what advice can you give to someone who struggles trying to establish a study schedule? I'm not trying to make an excuse for myself or anything, but just that's one thing I just I know what I have to do, and especially a job dictates it. But just trying to establish a routine and a study schedule, that's just something I struggle with. What would your best advice or tips on trying to do that?
Yeah, thank you. That's a really good question as well. So this is the first few certifications that I've done, so I'm fairly new to this. And what I did is just put time in my calendar. I wasn't always available to do it during the workday, to be fair. But if there was a bit of lunchtime here, some evening time there, I found if I actually committed to it in the calendar, it would be something to go for. And sometimes even silly things like a reward. If I passed a module, what's my reward at the end of that? Do I play Quake for half an hour? Do I I don't know if that's a great example, but do you get a chocolate bar? Do you get something that just kind of keeps that incentive and keeps me aiming towards the goal? And also I would say getting the certification as well. Actually aiming for them is setting the goal for me as well, which kept me disciplined, kept me aiming towards it. And it was something that if I was just to learn bits of Azure and cherry pick things and dip in here and there, I knew I wouldn't be getting a thorough foundation. It would just be it would be very bitty. So for me, it was all about committing the time, making sure I reward myself for putting that time in, and also not beating myself up if I miss a time. If I do miss that, can I make up for the time at the weekend, or do I just bump it off and go a bit easy on myself? Rather than, let's say, a full-on pressure might be to say, book the exam at the end of next week and I have to really cram. That may work for some people, but luckily I was under no time pressure to get it done, but I did want to set milestones. And if I could give a wee plug as well, I know Sarah's got a video coming up soon about how to prepare for Microsoft certifications. I wasn't paid for that endorsement, I'll be totally upfront, but I did see the reminder come up on YouTube. So, hearing from Sarah and Greg's study guides actually was a big help for me early days as well, seeing how do other people approach it too. So I hope there's a few tips there. Does that answer the question okay?
Yes, it does. Thank you. I really appreciate it.
Thank you. Yeah, good luck with the study.
Awesome. Anybody else for any questions? Oh, quiet. Well, here's a question. Have you, Gregor, on you go?
No,
on you
no,
go?
just-
No.
Oh, go for it.
How long do you normally take? So what I did was I would book the exam in like a month's time to force myself to concentrate. That was kind of thing that I did. Do you do anything like that? Or how long does it take you to study for an exam? Or is it just whenever you feel like you're ready, you just go for it? What's your method?
Yeah, no, that's a good question. So I'm studying towards the third certification for me now, and it's been two. So Azure Fundamentals, AI Fundamentals, and then the Data Fundamentals is the current one that I'm studying for. After that, I do want to get the Security, Compliance, and Identity. So they're the four before I sort of rise up to take on maybe an associate and progress a bit more. But actually, funnily enough, what you said there, Gregor, it's been about 3 to 4 weeks each time for me. And what I've done is I've actually had a study plan of, I want to do Microsoft Learn first. I find that's very thorough. If I can do that within a week or two, depending on the hours of content, let's say Azure Fundamentals, last time I checked, was about 9 hours of content reading. I'm not the fastest reader, so maybe it's nearer 10 or 11 for me. And then after I've achieved that, I'll maybe have a rest for a day, and then I'll look at one of these other options. Udemy, I was paying for some of those, and then Pluralsight, So if I could do 3 or maybe 4 of them, sometimes I get different speakers approaching things from a different angle, covering a thing that may be a bit more thoroughly than the other topic did. Microsoft Learn tends to be the king of them all for me, but some of the others, like Scott Duffy's great, and sometimes gives a bit more backstory, or, hey, I've been hands-on with this. I've actually found this little gotcha, or I found this little trick, and it's just cemented it a bit more in my mind. So far, it is about a month. And then I've had typically a week or 2 weeks as a breather in between, just to sort of decompress a wee bit. Or if I've got other things I need to catch up on that I've actually sacrificed to spend the time studying before I move on to the next one as well. I actually did also the last thing I did for the first certification, I did a similar thing to you as well, is actually did book it about 4 weeks in advance and say, right, you've put the flag in the ground, you've got to do this now, maybe you can reschedule, you don't want to cancel it, but okay, you're going to go for this. You've committed. But since I found with the other tips there, where if you can do the study days, the training days, and actually get the free voucher or the discount voucher, these days I've been waiting for those to come in, so when I book them, it's a discount or a free option as well. So yeah, that's typically been my path so far. I think I'll carry on that way as well, to be fair.
One last question as well. Sorry, I'll get.
Please.
Do you do practice tests as well? And if so, which ones have you found useful?
Yeah, another good question. So it was only recently I've got back to my Pluralsight subscription, and I noticed some of those come with practice exams. I've not taken any yet, but I'm looking forward to getting stuck in with them. When I've done the Udemy courses with Scott Duffy, the Azure Fundamentals did come with a practice test, but when I did the Azure AI Fundamentals Scott Duffy course, the level that I paid for it didn't, or I don't know if it even came with a practice exam. I've not gone for the official Microsoft practice exams. I noticed that you can either pay for a 30-day or a 60-day access to these official exams typically. I'm sure they're very good. To be fair, I've not asked around and I've not tried them. So if it's included in something I've purchased or a subscription, I'll try it. Or if to be fair, if I actually failed the certification exam, I'd probably take that a bit more seriously and then look into purchasing one of them.
Awesome.
Right.
Anybody for anything else? Oh, quiet. That was great. Thank you so much for coming along and speaking, Keith. I appreciate the time.
Thank you, and thanks for all the questions.
No worries. Our next speaker is Brett from AMD, and I see he's hiding in the attendee list. So, hey Brett, do you want to take over and do your presentation? Yep, I can see your slides, Brett.
Oh, beautiful. Well, you can't see me. Let me fix that.
Awesome.
All right. So, first of all, thank you so much for inviting us and giving us an opportunity to chat. I actually have a couple of mates with me here. Ross and Benjamin, are you here?
Yes.
Brilliant. All right. So, I only have 75 slides encompassing a range of topics. I really don't, but I'm going to take a few minutes to talk about AMD's sustainability efforts and some of the things that we're doing behind the scenes. And the reason I think this is important is because in our industry, everything is so often about speeds and feeds that all of the busyness that goes on around that seems to get lost. And I think it's important that if you understand kind of where the head's at of an organization, it gives you a better idea of where you think they might be going. And so the nice thing is the presentation is relatively short, and then hopefully we can have some time afterward for a bit of a chat. So let's go ahead and jump in and talk about this. Talk about kind of the mentality of AMD and how we are working to improve the world around us outside of just building faster processors. So essentially, it starts with every couple of years, we kind of look at our overall trajectory and the things that we're doing, and we set goals for ourselves. Now, the last time we did this on a major structured level was in around 2015, 2016. Now we've done this again in 2020, 2021 to kind of set our goals for the next 4 or 5 years moving forward. And this focuses on 4 areas. So it's our supply chain. Obviously, when you're a manufacturer, where you get the bits and bobs that go into what you do is increasingly becoming more and more important. The digital impact we have in terms of, all right, so now that we've got these processors, how are we making a difference with those? How are we making a difference that's different from the way others may do it? Environmental stewardship, which is, of course, incredibly important to us as well, is how are we doing this in a way that is environmentally responsible? And the final pillar of this is diversity. Sorry, my watch got busy. The last bit of it is diversity, belonging, and inclusion, which it's important that we have a good, strong, diverse group of people around us to ensure that all voices are heard and we're heading in the right direction. But let's break this down a little bit. So let's look at this first one, which is probably kind of the most evident to the user, the consumer, in terms of what are the things that we're doing. And we are in fact passionate about designing products that help improve people's lives. And either one of my colleagues that are on the line will attest to that fact that is front and center and top of mind in terms of how we approach things. And there's ancillary things that we do to kind of drive that. So, for instance, we have scholastic funds covering currently 24 universities. We're looking to expand that. Learning labs that we're piloting. We're going to look at growing that too. Right now, we're reaching about 700 students and teachers with these labs. And of course, there's our big iron initiatives in terms of exascale supercomputers dealing with climate science and all sorts of simulations. Biomedical is also becoming critically important to us. In fact, Benjamin and I, not too long ago, were just talking with a company in Switzerland that's doing some amazing things with very large scale AI simulations of pharmaceuticals. Now, our goal right now is for 100 million people to benefit from the AMD Foundation and its philanthropic endeavors through partnerships, through STEM education, reinforcement, scientific research, etc. So we're doing a great deal in terms of digital impact, both in the data center as well as finding on the ground organizations that we can work with. Now, part of that and part of that front end is ensuring that we have an ethical back end. So part of the key components in these pillars, as I talked about, is a responsible supply chain. So we work with our suppliers not only to take delivery of high quality products, but also what does that supply chain look like in terms of impact to the environment, in terms of impact to the worker and the surrounding environment. All of those things are heavily reviewed, heavily audited, and we take that very seriously. So in essence, a lot of our auditing standards are actually quite a bit higher than industry. So, and then on top of that, we are part of the RBA's board of directors to help guide and ensure that we're achieving its missions and visions. So our goals toward that end are 100% of AMD supplier manufacturing factories will have an RBA audit or equivalent by in the 2025 range. And of course, 80% of AMD manufacturing suppliers by spend will participate in a capacity building activity. So not only are we ensuring that they're audited to a specific level of responsibility, but they're also participating in giving back as well. Now, as we move into some of these other things that I tend to get more excited about, including our environmental stewardship, and Benjamin, you may want to comment on some of these as well, but our commitment to sustainability has really proven out over the last 5-6 years now in terms of how we are goaling ourselves. Like, for instance, I want to say it was back in 2015, 2016 that we had a drive to increase performance per energy cost by 25%. And we actually, a 25x increase. And we actually overshot that, delivering a 31.7 increase in performance per watt, particularly for mobile processors. So 2015, 2016, in those days, we were essentially providing value chips. So we were in affordable notebooks. We hadn't yet scaled to high performance yet, but we wanted to scale in a way that was going to be energy efficient. So that would translate into battery life being improved, as well as power consumption being as minimal as possible. So on top of that, from that same 2014 to 2020, we reduced greenhouse gas emissions by 38%, and that's well ahead of our 20% goal. So at the same time that we were looking at building silicon that was much more performant at less power cost, we were doing the same thing organizationally. So at the same time, we've continued procuring renewable energy and sourcing something like 34 million kilowatts in 2020, which was equal to 28% of our global energy use. So right about now, we are a third of our total energy in renewable, and we're looking to grow that ultimately to 100, but we're hoping to grow that past 50% in the next year or two, and then go on from there. We do have some more goals that I'll be talking about here in a few minutes, in terms of what we're looking to achieve by 2025. So looking at 50% reduction in greenhouse gas, 100% of AMD suppliers on a schedule of global greenhouse gas emissions reduction, and again, 80% of AMD manufacturing suppliers sourcing renewable energy. So not only are we in the hunt for increasing our reliance upon renewables, but we're pushing that down to our suppliers as well, to ensure that we're doing the best we can to be good stewards of the energy we have. Before I move on, I was curious, Ross or Benjamin, do you have anything to add to this one?
No, the only thing I was just going to say, Brett, is and you may have covered it somewhat already, is that it's really just down to, in terms of the chips themselves that are available, it's down to the manufacturing process being 1 or 2 steps ahead of Intel's, that mean that our chips are just much better at conserving energy than our competitors at the moment. And that's not to say that Intel won't catch up with us, or but at the moment our chips are just much less energy consuming. So
yeah, no, Benjamin, you're absolutely right, and that's a key thing. I suppose, speaking with my AMD hat on, obviously I would prefer Intel not to catch us, but in terms of energy consumption, it's great if we're having a race to the bottom on power consumption. Now, in an Azure data center right now, depending upon the configuration, we're delivering the same performance with 2.5 to 3 racks that our competitor is with 4. So right there, you're getting the same compute power at a substantially less energy consumption. And on top of that, we're doing some other things that are really quite interesting from a consumption and cost savings as well, in that we actually offer fractional GPUs. So if you have virtual machine requirements at a desktop level, and you want to use Azure Virtual Desktop, there are flavors of that offer fractional graphics support. Because if you spin up an instance that has a dedicated graphics card, it can actually be quite expensive, and in some cases cost prohibitive. But by fractionalizing the GPU associated with these instances, you can get the graphics horsepower you need at a fraction of that cost. So at the same time, where we're installing more performant processors at lower energy cost, we're also providing that same fractional benefit in GPUs. So a lot of good things that we're doing right there. Just to give some highlights of some of the things that we've done up till now in 2020. I realize 2021 is almost over, but I can't get the new slide until the year's done. So we've done a great deal here. 237 million kilowatt hours of renewable energy sourced. Reductions in water usage. Responsible sourcing at the supply chain level. 95% positive feedback from workers at AMD in terms of their work experience. 26 million for COVID-19 response, and 31.7x increase in energy efficiency from 2014 to 2020. But we're not done yet, and I have a little bit more that I want to share in terms of where we're going. Now, our goal between now and 2025 is another 30x in energy reduction. Now, this scale it shows the industry rate of performance per watt, and quite frankly, this chart makes me a little bit sad because it's actually logarithmic. So the 30x in comparison to industry rate just doesn't look as amazing as it actually is. But we are looking to do this at 2.5 times the industry rate. So how does that translate? Essentially, what that means is in 2025 timeframe. Now, we overshot last time. I can't commit with certainty that we'll hit this by 2025, but the way it would work is that, at that point in time, what it takes you to do a single computational cycle now will cost you 97% less energy in 2025. Now, that's a staggering savings if you think about that, promulgated out over an entire data center, whether it's on-prem or in the cloud, like in Azure, for instance. So there's a massive savings there in terms of what you can do with the same amount of horsepower. As we continue to shrink the die, as we continue to enhance and improve upon our chiplet design, we're seeing orders of magnitude of reduction in energy requirements that are just mind-boggling. Now, it's a tall order because it obviously does get harder to 30x, every 5 years, because the scale you're working with does get quite difficult to continue to do that kind of performance. And in fact, I wanted to finish off here with a quote from Madison Snell, who's the CEO of Intersect 360 Research. Future gains are more difficult now as the historical advantages that come with Moore's Law have greatly diminished. A 30 times improvement in energy efficiency in 5 years will be an impressive technical achievement that will demonstrate the strength of AMD technology and their emphasis on environmental sustainability. And he's right, it is a tall order. The things that we're trying to achieve, some of that is going to happen with technology that's not yet built yet. So to come out and say this is, we're definitely aiming for a target that is not quite materialized yet, but I feel confident that we'll manage to do that. So that's essentially kind of a breakdown of what AMD is doing in terms of being a responsible company by looking at where we can improve our environmental situation, where we can reduce our carbon footprint, and while we can hopefully create the next generation of processors that perhaps will work to solve some of the problems that we're facing right now. So it's an exciting time to be in this space, and we know that great minds are going to use these kinds of tools to solve great problems, and that's inspiring to me. And it's one of the things that makes it a joy for me to come to work every day. So hopefully you found some value in this too. I want to give my colleagues a chance to comment as well. Do you have any thoughts on this, Benjamin or Ross?
Thanks, Brett. Sorry, I was on mute. I'm exactly the same as you. I absolutely love working for AMD, really, because of the great stuff that seems to be going on. And, it's a joy being able to talk to people about the differences and the way that the technology is improving every day, basically. I've put a link into the chat which gives a bit more information about the goal that we've set ourselves to 2025, which is obviously, as you say, reducing our energy consumption by 97%, which I still find quite difficult to grasp myself, but I firmly believe that's what we've set ourselves as a goal, and we'll be doing our damnedest to achieve that. So I just applaud everything you said, Brett, and would welcome any questions from anybody if now's the time for that.
Well, I'm out of slides, so I would say yes. Now's the time for that.
That was awesome. Thank you, Brett and Benjamin. Is anybody any questions? Oh, I see we've got a hand up. the other Benjamin, do you want to come off mute and ask the question?
Hey guys, that was quite interesting. Unfortunately, I'm talking on a Team Blue laptop here, but in my other room, I've got a lovely AMD desktop, and it's fantastic. I'd like to talk about the other sort of CPU processors at the moment. Apple are doing some massive things with the M1 and the ARM processors, and I'm wondering if AMD's, and they're meant to be really good for power consumption. I've seen like the statistics of the laptops lasting for 16 hours or something ridiculous. And is AMD looking into ARM technology?
You're totally right. I mean, one thing to just jump in quickly. I'm sure you've got plenty of things to say about that, Brett. But I was just going to say that Apple uses the same Taiwanese manufacturer that AMD uses. It's the Taiwan Semiconductor Manufacturing Company, TSMC, to make their chips. And you may have seen the launch of the new MacBook. They had some slides up which showed performance and power consumption, and absolutely it was saying that they've got some really impressive statistics for power consumption and how long the MacBook can last for. Yeah, I mean it's ARM based, so it's not x86 like all Intel's chips are. So we're absolutely aware, and we actually use ARM in some of our chips at the moment, but for standard sort of cloud-based instances, virtual machines, we have an x86 platform. So anything that works on Intel will work on AMD. Whereas companies trying to move legacy type workloads and applications across to ARM-based chips will need to recode, and that can be a problematic, long-winded, expensive process to do that. So over to you, Brett.
Yeah, you're quite right, Benjamin. There's so when you look at and I'm quite familiar with Macs. I have several of them myself, and I understand the kind of the appeal of the Apple Silicon, because you think, okay, huge power savings, pretty impressive performance. Though I have to say that in their launch events, they're a bit dodgy in posting the statistics on real world performance. But yes, I agree, they are performing. But there's a trade-off for that, right? There's a trade-off in all things where you get that performance, and you see that on the iPad Pro, you see that on the Apple Silicon, and they're innovating very rapidly on that. But again, it's a walled garden, and we believe in the next couple of years that we can achieve the same degree of or better power consumption while remaining x86. So essentially, we can give you that kind of power savings without you having to recode and recompile all of your apps. And I think that when you look at the energy consumption and manpower and whatnot of doing all of that, it's a very definite trade-off just to get to an ARM-based platform. So and there are some trade-offs with that as well. I know that certain hyperscalers are using some ARM-based stuff in the cloud, but that there are some limitations with that. For instance, our confidential computing scenarios are pretty impressive, and I don't think that level of encryption has been achieved in an ARM platform yet. I might be wrong, but at any rate, the idea that you have to trade compatibility to get that extra performance at a power savings it's a bit of a red herring. We think we can provide it if we're pretty close now. We just need a little bit more time.
Thank you. That sounds quite exciting.
I think so.
Anybody for any other questions? We've got a quiet bunch tonight.
Yeah, it's I know it's a lot of facts and figures, a lot of data, but for me, the thing that's most impressive that I've seen, and I have not been at AMD a terribly long time. In fact, Benjamin hasn't either. But at the same time, we're really excited to be here because we legitimately see that we are living this stuff. We are trying to get to the point where we are super energy efficient, super environmentally conscious, and we're living that day to day. So it's exciting. It's nice to be able to be a part of it, and see how we will continue to grow this.
I think it's safe to say that in the last couple of years there's been a lot of companies, AMD one of them, that have been driving the innovation, where there's other companies that have maybe tried to stay still and maybe just keep their existing customer base. I can think of a couple of products, I'm not going to name names, but where the innovation is really being driven. You can see the energy, you can see the enthusiasm from leadership down to everybody that works there, and that's where everybody's moving towards. I know I've changed some personal tools and stuff that I use because of that innovation, and I think it's quite easy to see that AMD are actually trying to lead the way instead of just kind of following what everybody else is doing. So yeah, exciting to see where it's all going, for sure.
Well, maybe we can come back when we have some more stuff to announce and talk about some of the new things that we're doing that we can't yet talk about.
Yep, absolutely. Always welcome. Always welcome. Thank you, guys, for that. I think we're now at the part where we play the quiz. And before I let the AMD guys go away, what is the quiz prize again? I wasn't sure what you'd actually secured. Brett, can you remind me what the quiz prize is going to be?
Okay, so it's a cool prize, but it'll take a while because we're giving away a nice jacket and a mug, but I need to know a size before I can get them to send it over. And unfortunately, it's coming from America, so it'll be a little while.
That's awesome. No, I'm sure it'll be worth the wait. So thank you again for supporting the user group and giving that awesome prize. Okay, let me go and set up the quiz, and then we can do that. Unless there's anybody else for any other questions or random chat, well, we have the group here. Please feel free to come off mute. Awesome. Thank you so much, everybody. We are hoping to do another meetup in February. Whether we'll be virtual or whether it'll be in person or whether it'll be in some kind of hybrid mode, who knows? We will see what the new year brings for us. But hopefully we can all get back together again in February at some point. Thank you so much for your awesome support, as always, at the Glasgow Azure User Group. It's a labour of love for Gregor and I to do this, so appreciate the support, and yeah, thank you, everybody.
Hey,
Well done,
no
all,
worries.
guys, well done.
Thanks for putting it on, guys.
Thanks, everyone.
Thanks, everyone. Have a lovely Christmas.
Cheers all.
Yeah, you too. Have a nice Christmas, everyone.
Yeah, have a good Christmas. Thank you.
Bye.